Number 1, write a function that would represent a quadratic relationship. When you hear the word quadratic, tell me what you know.
4.
Squared. Okay? For a function to be quadratic, the x must be squared. So to write a function, you could put y equals x squared. Now, you could have added more to that, like you could have put y equals x squared plus 5, and that would have just shifted the parabola up 5 units. Okay, you could have put x squared minus 2. You could have even put a negative in front of the x squared. It's still quadratic, it just causes the parabola to flip upside down. Okay? But anytime the x is squared, it's a quadratic relationship. Number 2, write a function that would represent a linear relationship. Y equals x would work. Because what's important here with it being linear is that the x is raised to the first power. Okay? So like y equals 2x plus 5. Is that a linear relationship? Yes, the x is raised to the first power. 2 is your m, 5 is your b. Y equals mx plus b is a linear function. Alright, number 3. Okay, before we do number 3 though, it didn't ask about a cubic relationship. What would a cubic relationship look like? X cubed. Y equals x cubed. Okay, number 3, write a function that would represent an exponential relationship. Well, not always a 2. It does have, it has a number greater than 1, so we'll just...
2 and then the x.
Right, in an exponential function, the x is the exponent. So it could have been y equals 2 to the x, 3 to the x, negative 5 to the x, negative 1/2 to the x. It's just the x is the exponent in an exponential function. Any questions so far? Alright. Use the following functions for questions 4 through 7. So we're going to be using function f of x and g of x to answer 4 through 7. Number 4. Find f plus g of x. Well, what do they mean when they say f? The 3x minus 2. And what do they mean when they say g? Okay, and what do they want you to do with those two functions? Add them. What kind of functions are each of those? Linear, quadratic, cubic, or exponential? Linear. Aren't they both in the form y equals mx plus b? And their x is raised to the first power? Those are both linear functions. And they want us to add them. Now that I have it set up, what do I do? Right? Well, right, we really don't need the parentheses at this point because there's nothing to distribute. Okay? I can just combine like terms. 3x plus 7x is, and so now look, 3x and 7x are gone. We added them together and now it's 10x. And then we're left with a negative 2 plus 3, which is positive 1. And so that's the answer, 10x plus 1. Alright, number 5. This time they want you to take those same two functions, f and g, but instead of adding them, they want you to subtract them. Okay, what's different when we subtract? What do we have to do different? Right, this negative sitting on the outside, it doesn't just belong to the 7x, it belongs to the entire g of x function, which is the 7x and the 3. So you have to distribute it to both. Now this part is not affected, so it just comes down. But when you distribute this minus sign to the 7x, it becomes minus 7x. When you distribute it to the 3, that becomes minus 3. Now we're ready to combine like terms. What can be combined? Okay, so we have a 3x minus 7x, which is negative 4x. So now we're done with that, and we're done with the minus 7x. Now all we're left with is negative 2 minus 3, which is negative 5. So that's the final answer, negative 4x minus 5. Okay, number 6. This time they want you to take those same two functions, f of x, which is 3x minus 2, and g of x, which is 7x plus 3, and what do they want you to do? Multiply them, which means since they are both binomials, we will FOIL them. Now, when you multiply, do I have to write a dot right here? No. If there's no sign at all between them, then it's understood that we're multiplying. Okay, so we're going to FOIL them. What does the F stand for in FOIL? First. So, like 3x is the first one over here. What's the first one over here? So we multiplied those. What's 3x times 7x? Right. The 3 times the 7 makes 21. X to the first times x to the first makes x squared, because that 1 plus 1 adds up to 2. Okay, so now we've done the F in FOIL. Now we move to the O. What does the O stand for? Outer. 3x and 3 are the most outside terms of the problem. So when we multiply those, we get a 9x. Okay, so we've done the outer terms. Now we move to the inner terms. If 3x and 3 are the outer, what's the inner? And when you multiply those, you get a, right? And then we go to the last term of each one. Well, if 3x and 7x were the first, what are the last? Negative 2 and 3. And when you multiply those, you get a, okay, are we done? Why not? Okay. Can 21x squared be added with anything? No. So it just stays 21x squared. Okay, and then mark it out because you're done with it. You can't use it again. Can 9x combine with anything? The negative 14x. And 9x minus 14x is, right? And then all that's left is minus 6. So it would just come down. Okay? Alright, number 7 is another subtraction problem. But this time, instead of us doing f minus g, we're doing g minus f. So the g function will come first. And then we subtract the f function from it. Okay, and what's the most important part to remember here? To distribute that minus sign to everything in the f function, not just the first thing after it. Okay, so this stays 7x plus 3. What will all this become once you've distributed that minus sign? Right. Basically the opposite of what it was before, like Jordan said. Okay, now what do I do? Okay. What can I combine the 7x with? Okay, so what is 7x minus 3x? Positive 4x. Because you're just doing 7 minus 3, so positive 4. And then all you're left with is 3 plus 2, which is positive 5. Okay, now look. Back in question 5, when we did f minus g, we got negative 4x minus 5. When we reverse the order into g minus f, look, almost the exact same answer, just opposite signs. Okay, that'll happen like that every time. Okay, number 8. I'm going to have to erase. Can I erase? Alright, number 8 says, find g of f of 3 if f of x equals x squared and g of x equals 2x minus 6. Okay? What should I start with? The f, because it's on the inside, and what do I plug in the f? 3. Okay, so I'm going to the f, but instead of the x, I'm going to plug in a 3. What is 3 squared? So f of 3 actually equals 9. So now what I have left is the g with a 9 in parentheses. So now what do I do? Right, I go to the g function, 2x minus 6, but instead of the x, they told me to plug in 9 into the g. And so 2 times 9 is, minus 6 is 12. Okay, everybody understand? Alright, let me just erase this and then we'll be able to see. Okay, number 9. It's kind of the same. It's the same kind of problem. It's composition of functions. But what's different about number 9? They don't give us a number to plug in for g. So what does that mean we have to do? Plug in the entire g of x function into x, correct? I mean into the f function's x. So instead of x squared minus 2, they've told us to replace the x with the g of x function, which is x plus 8. See, all I've done is take the entire g of x function, because it's on the inside, and plug it into the f function's x. Now, what does x plus 8 squared literally means going on? you're multiplying it by itself. So like had it been x plus a cubed, we would write it how many times? 3. Okay, so now when you see this, what word pops in your head? FOIL, okay, so what do we multiply first? And that makes, okay, what do we multiply next? And that makes, okay, then what do we multiply? Which makes, and then what do we multiply? Which makes, okay, and then don't forget about this minus 2 that was hanging on the outside. Bring it down. And now what do I do? Combine like terms. Okay, starting with the x squared. Can anything combine with it? No. So just bring it down and then mark it out so you know you're done with it. Then we move to the 8x. Can it combine with anything? Which makes 16x. Okay, then we move to the 64. Can it combine with anything? 62. Okay, any questions off this page? Okay, flip to the next page. Then, what happens to the graph of f of x if it becomes f of x minus 7? So, like if you take any function and subtract 7, what happens to it? It moves down 7. Okay? What happens to the graph of f of x if it becomes f of x plus 6? Left 6. Okay, let's talk about the difference here. If it is an outside number, see how that minus 7 is on the outside of the parentheses? Then it moves up or down. And it is what you would think it is. Minus 7 is down 7. Had it been plus 7, it would have gone up 7. But inside numbers, things that are inside the parentheses or inside the absolute value bars, or if it's an exponential function like 2 to the x, if it's up there, that's a horizontal shift, left or right. If it's big, it's a vertical shift. Okay, that's for exponential though. Okay, so if it's inside, then it moves left or right. And it's the opposite of what you would think it should be. Plus 6 actually means left 6. Minus 6 would mean right 6. Does that make sense? Okay, number 12. What happens to the graph of f of x if it becomes 1/2 f of x? It will shrink. Okay, another acceptable answer would be less steep. Okay, and let's talk about that for a second. For f of x, I'm going to use a quadratic function. So I'm going to go to the calculator. Let me clear out what I've done before. And I'm just going to graph a quadratic function. So if I'm graphing a quadratic function, what do I need to type in? What? What does it mean to be quadratic? The x is raised to the second power. Okay, so if I graph that, what number is out in front of this x? A 1. Okay, so that's just a parabola. That's just y equals x squared. Now, if I go and I graph a second parabola, but I put a 1/2 in front of it, okay, alpha y equals to get to the n over d button. And then instead of 1, I'm going to put a 1/2 in front of the x squared. Let's see what that 1/2 does to it. It makes it less steep. See how this red line is less steep than the blue one? That's also called a shrink. Okay, let me show you. Let's look what would happen if we used a bigger number than 1. Say we use like 2x squared. Look, it got steeper. The bigger the number is, the larger the number is, the steeper it is. Okay, now, say that you take this 2 and you throw a negative in front of it. What do you think that's going to do? Do you think it's still going to be the same steepness it was? Yeah, the 2 and 2 are going to be equal steepness. The negative, all it does to it is turns it upside down. But see, isn't that the same steepness as the black one? Okay? The negative just reflected it. Okay. Number 13. Write an equation that could represent the following graph. Okay, well before we just start trying to write the equation y equals blah blah blah, tell me what you notice about the graph. What are some characteristics you notice? Okay, it is quadratic. It's positive. Okay, with it being quadratic, what does that mean we have to put in the graph? X squared. Okay, and positive means that it's going to be a positive x squared. What else do you notice about this? Did it start at the origin? So it's been shifted. How has it been shifted? Up 3 and to the right 1. Okay? Remember, up and down are outside numbers. Left and right are inside numbers. So if I'm trying to write this, it needs to be inside since we have a horizontal shift. How do you represent right 1? Minus 1. Remember, the horizontal shifts are the opposite of what you would think they should be. And then since it's quadratic, we've got to square all that. And then how do we represent that up 3? Plus 3 on the outside. So like watch, had it just looked like this, had it just started at 3 and opened up and it hadn't shifted to the right, it would have been y equals x squared plus 3. But since it shifted right, you have to put that minus 1 on the inside, which throws the squared to the outside. Does that make sense? Okay, number 14. Sketch a graph of an even function. What does it mean to be an even function? Symmetric, but symmetric to the what? The y-axis. Okay, so let's say we have a parabola, a quadratic function. Is that symmetric to the y-axis? Yes, I mean, my drawing is not perfect, but if you folded it over the y-axis, this half of it would land on this half. Now, say that I take that parabola and I shift it up 3 units. Is it still even function? Yeah, it's still symmetric to the y-axis. So moving it up or down the y-axis will not change the fact that it's an even function because it's still symmetric. What if I take it though and I shift it over here to 5? Is it still an even function? No, it's no longer symmetric to the y-axis, even though it's the same function, because we shifted it off of the y-axis. Does that make sense? Okay, next question. Sketch a graph of an odd function. What does it mean to be an odd function? Okay, it has to go through the origin, but what else does it have to be? Symmetric, right. Symmetric to the origin. Now, symmetric to the origin means if you fold it over the x and the y-axis and it lands on itself, that's symmetric to the origin. So, remember yesterday we were doing cubic functions and they look like a snake? And that one passes through the origin. Okay, to be odd, it has to pass through the origin. Think about it. If I flip this part of that function over the y-axis, won't it appear right there? But then if I flip it now over the x-axis, won't it land on itself? So that means it's odd. It's symmetric to the origin. Now, if I shift this off the origin, up, down, left, or right, will it still be odd? No, it must pass through the origin to be odd. Okay? It won't be symmetric to the origin if it doesn't pass through the origin. All right, number 16. Is the following graph even, odd, or neither? Even. That's symmetric to the y-axis. Look, here's the y-axis. If you take this half of the function and reflect it over the y-axis, won't this hump land directly on top of that one and this curve over here land right here? So that's symmetric to the y-axis, so it's even. Okay, number 17. Is the function represented by this table even, odd, or neither? Okay, well, how would you figure it out? Very good. The best way to find out is to take these points, go to a graph somewhere else on your test tomorrow, and plot them. What's the first point? Okay, so here's -4, 6, 7, 8, 9, 10. So about right there. What's the next point? Okay, 6, 7, 8. What's the next point? Okay, what's the next point? Okay, what's the next point? Okay, and the next point? And the final point? Okay? Does that graph have any kind of symmetry? To the what? So it's even. Is it a function? Yes, it would definitely pass the vertical line test. Is that a parabola or an absolute value? Let's look at the slope. To get from this point to this point, you go up 2 over 2. Do you have to go up 2 over 2 to get to that point? No, over 1. So is the slope continuous? So it wouldn't be a straight line, so it couldn't be an absolute value graph. It would be a parabola. Okay, but that was just extra. It is even because it's symmetric to the y-axis. And it's a quadratic function, yes. Okay, number 18. Would the function represented by the table have an inverse function? So what they're asking here is, they give you a table. They want to know if you do the inverse of that table, would it be a function? Well, is the original table a function? Okay, look at this side is our boys, right? Did any boys go on more than one date? No. So there's no possibility of cheating if you didn't go on more than one date, okay? But if you take the inverse of that table, won't the girls now become the x values? Okay? So we basically change it around and it would be 10, -4, 8, -3. Because remember, when you find the inverse, you just switch the x and the y's. So now when you look at it, do you have cheaters? Yes. How many cheaters? 3. This one was the only one that didn't cheat. Everybody else cheated. 10 cheated, 6 cheated, 8 cheated. So the inverse is not a function. The original one was a function, but when you do the inverse of it, when you switch all the x's and y's, it's no longer a function. Okay, can I go to the next page? All right, number 20. Draw a graph whose inverse graph would not be a function. Okay, we did a lot of these yesterday. What kind of graph could I put on there where if you did the inverse of it, the inverse would no longer be a function? Right, remember yesterday when we were doing parabolas? And then when we took the inverse of it and graphed it, it looked like that, and so it was no longer a function? That's what this question is talking about. I mean, really, all the question is asking for is the original graph, which is this. All right, number 21. Find the inverse of f of x equals 8 minus x. What's step 1 for finding the inverse? Well, where is the y? Right, f of x is the same thing as y. So once I've switched the x and the y, what will it look like? Okay, what's step 2 for finding an inverse? Okay, get y by itself, solve for y. So how would I do that? That 8's positive, so to cancel it, you subtract it. The y is negative, not the 8. Okay, so now I'm left with x minus 8 on the left side, and on the right side, what am I left with? Negative y. Well, isn't that a negative 1y? So now to get y by itself, what do I have to do? Divide by negative 1, and I divide both of these over here by negative 1. So now, what is x divided by negative 1? Negative x. What is negative 8 divided by negative 1? Positive 8. And then over here, what's negative 1 divided by negative 1? Positive 1. But do you really have to write the positive 1 beside the y? Nope. So you're done. Okay, can I erase that now? All right, number 22. Find the inverse of f of x equals 5 plus x over 7. So what do I do first? Okay, well, I need to go and make this a y, and then I can switch it. And what will it look like when I've switched it? Okay, then step 2 is get the y by itself. So what do I do? Right, it's divided by 7, so to undo that, you have to multiply by 7 on both sides. On this side, the 7 and the 7 reduce, and you're left with 7x equals 5 plus y. Now to solve for y, what do you have to do? Right, that's a positive 5, so to cancel it, you subtract 5 and subtract 5 over here. Now, those won't actually combine. You can't combine a 7x minus 5, so it just stays, and then equals y, and then you're done. Can I erase now? Okay, number 23. What do I need to do first? Right, make that a y and then switch them. What will it look like when I've switched the x and the y? Excuse me. Correct. Now step 2 for finding the inverse is, okay, get the y by itself. So what do I have to do first? Add the 3, cancel, add it over here. So now you have x plus 3 equals negative y. Now to solve for y, what do I do? Right, this is a negative 1 being multiplied by y, so divide by negative 1. Okay, so what is x divided by negative 1? What's 3 divided by negative 1? And then equals, those cancel to 1, y, and you don't have to write the 1 beside it. Alright, last problem. Go ahead and make this, okay, this is a typo. If this says f of x, it should say 4x. If you wanted to say n, you would have had to put an n over there. You can't have two different letters like that, but it's just a typo. Okay, but we need to go ahead right away and just change all of this to a y and this to an x anyway. And then we'll switch the x and the y. So what will it look like when I've switched them? Okay, now I need to solve for y, so what do I do? Okay, so multiply by 9. Multiply this by 9, you're left with 9x equals 4y minus 4. Add the 4 to the other side. So now you have 9x plus 4 equals 4y. Right, divide by that 4. Divide this by 4 and this by 4. Those cancel, leaving y by itself. Can you reduce 9 over 4? No, so you'll just leave it 9 over 4x. Can you reduce 4 over 4? To a positive 1. And then you're done.